Hello folks, welcome to your video for section 7.3. This one I actually recorded just on Tuesday, so it's more up to date than the other one. All right, so section 7.3, we are going to be talking about similar polygons, our objectives for the day, identifying similar polygons. What do I mean by similar? We need to define that term, and then we're going to be using them to solve a couple of applications. We're not going to do too many applications problems today. Maybe that's something we can work on a little bit more next week when I get back. But we're going to do a couple like that. All right, so let's get into it. Here's your definition. So similar figures, and I'm broadening it instead of just saying polygons. Similar figures have the same shape, but not necessarily the same size. And I'm going to circle, but not the same size. We are going to use a symbol here. So is similar to. If I'm trying to say that a polygon is similar to another polygon, I'm going to use a squiggle, all right? So for instance, I could say, hey, ABCD is similar to polygon GHIJ, all right? So that little squiggle just means is similar. So they're the same shape, but they're going to be different sizes. Let's go ahead and draw these out. So here is my random quadrilateral. I'm going to call her A, B, C, D. And I'm claiming that she is similar to this other guy, GHIJ. GHIJ. Now, in similar polygons, we know that all corresponding angles are going to be congruent. For instance, angle A and angle G. I can say angle A is going to be congruent to angle G. I can say that angle B is going to be congruent to angle H. Angle B congruent over there to angle H. Another way you can check is, hey, B is the second letter, H is the second letter. So they are going to be corresponding angles. They must be congruent to each other. I can say that C and I, angle C, ooh, the yellow on the tan is pretty rough. Angle C is congruent to angle I, and then lastly, angle D and angle J. They must be congruent to each other. All right, so again, in similar figures, corresponding angles are congruent, but the sides are definitely not going to be congruent. Corresponding sides, however, so these are the corresponding angles. Corresponding angles are congruent. Corresponding sides are proportional. Proportional. So what I mean by that is the ratio of side AB to side GH is going to equal the ratio of side BC to HI is going to equal the ratio of CD to IJ, which will equal the ratio of side AD to GJ, all right? And this is called an extended ratio or proportion, extended ratio or extended proportion. Proportion. Hopefully you guys read about those a little bit in section, I think it was 7.1. It wasn't in the other video that I could give you guys, but an extended ratio is saying, hey, I'm just going to kind of keep on going. We're usually used to just kind of stopping like here with two things. The extension is saying, okay, it's also equal to this. It's also equal to this, all right? Okay, so that is your definition for similar polygons. Everything we do today is going to come back to this. Here's our first example. So take a moment, draw in these two triangles in your notes. They're telling us over here that triangle MNP is similar to triangle SRT. Remember, the order of the letters is helpful here. So what are the pairs of congruent angles? Well, I need to know what my corresponding angles are. So M is the first letter, S is the first letter. That must mean that those are corresponding and therefore congruent angles. So M is congruent to S. Our second letter is N. Second letter, and the other one is R, so N and R must be congruent to each other. And then whatever is left, we have angle P must be congruent with angle T. So this angle over there is congruent with this angle over there. So now they've kind of turned one of the figures, one of the polygons a little bit. They're not lined up so nicely. When that happens, just make sure, use the order of the letters to help you out. What is the extended ratio of sides? Okay, so pick any side to start with. I'm going to start with MN over here because it's my first two letters. So the ratio of MN to SR, again, I'm getting that from MN is the first two letters, SR is the first two letters. These two sides, the ratio that they make is going to be equal to the ratio of my other corresponding sides. So NP over RT, and that's also going to be equal to our last pair of sides, MP over ST. So again, I can't say this enough. The sides are not equal, but the ratio that they create holds true for all pairs of corresponding similar sides, all right? So that's our first example. We're going to be able to use these ratios to help us solve for some unknowns. That's kind of where we're going to start heading. Before we do that, we need to define one more thing. A scale factor, and this is where like real life applications actually show up a bunch, is the ratio of corresponding linear measurements for two similar figures. So for instance, I could have corresponding sides. Maybe side BC is 20 inches. And I don't know, maybe YZ is 8 inches, all right? And these I'm saying are in two separate figures, two separate diagrams, but they're corresponding. So I know I can set up a ratio with them. The scale factor is that simplified ratio. So the ratio of BC to YZ is 20 inches to 8 inches. Simplified, we just get 5 over 2. So for this one, our scale factor is just a 5-to-2 ratio, or 5 over 2. Scale factor is super helpful, especially when you're thinking about something like a blueprint. You're going to have like the model. So I don't know, maybe I'm trying to make like a model rocket, right? I'm going to have the model, and then I'm going to actually have the real life thing. And this one is going to be much, much bigger, but you're going to have to use proportions. You're going to have to use ratios to make sure all of your units are correct. So the scale factor would be like, maybe the model is 1/4 of your overall thing. That would be a 1-to-4 ratio. Maybe the model is a 2-to-5. So every time you have 2 inches on the model, that's going to correspond to 5 inches on the real one. All right, so that's kind of where scale factor is going to start playing a role in the real world. Okay, let's keep moving. Example 2, we're going to split this one up into 2 parts. So 2A, we're going to deal with these polygons. First, they're just saying, hey, are these similar? What I want to do is I want to see, do I have 4 pairs of congruent corresponding angles? We can jot down over here. I see that M and W are congruent. So angle M is congruent with angle W. The ones with 2 arcs are angle J, so that's congruent with angle T. Then we have angle K is congruent with angle U. And lastly, we have angle L is congruent with angle V over there. So with the angles, so far so good. We have 4 pairs of congruent corresponding angles. That's good. Next, and that's kind of part 1. Next, I want to check, do all sides have the same ratio? So I want to compare the ratio of sides, and you can pick any 2 sides to start. For this example, I'm going to actually just run through all of them real quick. So for instance, JM over TW. So I'm looking at this side compared with this side. Well, that just says it's a 6/6 or 1-to-1 ratio. And again, remember, if we're dealing with ratios, I do actually want to leave that 1 on the bottom. A ratio must have a numerator and a denominator. Okay, so if they're similar, then I should get a 1-to-1 ratio for every other pair of corresponding sides. Let's check out JK and TU next. So JK over TU, and you guys probably looked ahead and saw, oh wow, 12/6. That's going to be very different, all right? So just by that alone, we know that these are not similar. They do not have the same ratio for all 4 sides. But just for the sake of practice, KL, we're going to compare her to UV. KL, UV, we would get 24/16, which would simplify it into a 3/2 ratio. And then our last one, we're comparing ML with WV. ML with WV, that would give us 24/14. Both of those I can just divide by 2. That's going to give me a 12/7. So literally none of these are the same. But the second that you have 2 that are not the same, that's enough to say, hey, these are not similar. The ratios are just not equal. All right, let's move on to another example. Following this one, we're moving into example 2B. Again, they're asking us, are the polygons similar? So I can tell based on the diagrams, I do have 3 pairs of congruent angles. I'm not even going to necessarily, you know what, I'll write them out. So I have angle C is congruent to angle F. I have angle A is congruent to angle D, and angle B is congruent to angle E. All right, so far so good with the angles. That's always step number one. Check your angles, then check your sides. So the ratio of AB to DE, is 12 to 15. I can simplify that to 4 over 5. The ratio of AC to DF is 8 over 10. Simplify that to the 4, 5. Great, we're looking good. The last one, BC compared to EF, is going to be 16 over 20. And again, that simplifies to 4 over 5. So all three of these are equal, which means triangle ABC is similar to triangle DEF. Again, order of letters matters. I know how to order the letters over here because we said that A and D were corresponding and congruent, B and E were corresponding and congruent, so I'm using that order to help me out. And the scale factor is 4 over 5, or a 4 to 5 ratio. All right, we have a couple more examples. You guys will be doing a lot more practice. There will be a worksheet that you guys can print out to keep on practicing with these types of problems, but we have a couple more we'll do together. So this next one, they're telling us, okay, I have four-sided shapes here. I have some quadrilaterals. They look, wow, I just keep yawning. They look like trapezoids, but I don't know that they are. I just know that they're four-sided shapes and they're similar. What's the value of x? What about y? So for this problem, to solve for x, I do want to use a similarity statement. I want to write a proportion. So I know that FG, or x, it looks like it's corresponding with BC over there. So I can say FG over BC equals some other set of sides. Here I want to use some that I know. So I think I'm going to use ED, and then I'm going to use AD. All right, so I'm going to say this is equal to ED over AD. And now I can replace those with their actual value. So FG is just x. Don't know where the ruler came from. Over 7.5, that's what BC equals. ED is just 6. Over AD is just 9. And now we can cross multiply. This is what was talked about yesterday a bunch. I can cross multiply or use your butterfly method. So 6 times 7.5 on the one side. And I'll have x times 9, or just 9x on the other. So we're getting 9x equals 45. Divide both sides by 9. We're getting x equals 5. All right, so that is what 5 is. If you ever want to check it, just throw it back into that ratio. 5 over 7.5. Yeah, that does simplify to 2/3, which is the same thing as what 6 over 9 simplifies. So your scale factor is a 2/3 ratio. We're going to do the same exact thing with y. So y is side EF. That looks like it corresponds with AB. So I can do y over 5 equals, let's just use 6 over 9 again. We know that ratio. We know it works. And you could simplify 6 over 9 first if you want to. Either way, you're going to end up simplifying things. Divide by 9, divide by 9. Okay, so y ends up giving us a fraction, 10/3. Or if you prefer decimals, we'd get about 3.3. We tend to like fractions just because they give us a more exact answer. But you guys might have some problems on your next like assessment or whatever where you will have something that says round to a decimal place. All right, that's example 3. And again, with any of these, make notes. If you want to talk with me next Monday, Monday is going to just kind of be our catch-all day. Tuesday, we'll have some type of activity or classwork thing, or, something that will be a little bit graded, but don't worry too much about it. We will catch everything that we need to catch on Monday. All right, example 4. So here is an example that is a word problem. Your class is making a rectangular poster for a rally. The poster's design is 6 inches by 10 inches in length. So that's what they're giving us over here, the design. The space allowed for the poster is 4 feet by 8 feet. So what are the dimensions of the largest poster that will still fit in the space? First thing I want to do is I need to make sure that I'm dealing with my units properly. So I would like to convert the 4 feet and the 8 feet into inches. So 4 feet is going to be 48 inches. I'm just doing 4 times 12 to get 48 inches. And then for 8 feet, converting that, I'm doing 8 times 12, that's going to give us 96 inches. So I want to start with one of these. This one is representing the width, this one is representing the length. How many of our 6-inch widths could fit in 48? So I'm just going to take 48 divided by 6. I could comfortably enlarge the poster times 8, and it will still comfortably fit in the 48 inches that are allowed. Let's now check our length. So over here, okay, I have 10 inches. So how many 10 inches will fit in 96? How many 10 inches fit in 96 inches? 96 divided by 10, that's going to give us a decimal of 9.6, all right? So these are kind of your two options. You could either enlarge the design by 8. That's the number that we got when we compared the widths, or we could enlarge it by 9.6. Choose the smaller number with a problem like this. So choose the smaller one. It's okay if I have some extra space, but I can't go overboard, right? Like if I choose the 9.6, then I would also have to multiply the 6 inches by 9.6. That's going to be way too big. That's going to end up being much bigger than 4 feet. All right, so make sure that you are choosing the smaller number. Our final answer, the design may be enlarged. The design may be enlarged 8 times. I'm going to multiply all my dimensions by 8. Alrighty, folks, we have one more example. This is a 6-parter. So take a moment to draw in your diagram. We have a couple of triangles over here, and they are telling us that triangle ABC is similar to triangle ADE. So everything we know about similar figures, we can apply over here. First thing they want us to do is find the scale factor from triangle ABC to ADE. To do that, I want to find 2 pairs of corresponding sides. I think let's use side BC and side DE. So 12 over 21, I could simplify that. I could divide both of those by 3, and it's going to give us 4 over 7. So 4 over 7 is our scale factor. Next up, they want us to solve for x, find the value of x. So here I need to set up a proportion. Let's use the pair of sides that we already know. So the 12 over 21, that's good. And then x is over here. I'm going to have to be consistent though. So if 12 is side BC for my smaller triangle, then I'll use side AB over here, so 10. But then what is side AD? It's actually going to be 10 plus x, or x plus 10. So now you can use your butterfly method. We're going to get 12 times x plus 10 equals 210. That's just 10 times 21. 12x plus 120 equals 210. 12x equals 90, x equals 7.5. So that's what we're getting out for x. Remember, once you set up your proportion, do your butterfly method. If you have some extra terms, like over here I have x plus 10, make sure that you are distributing to both of those. Next, they want us to find the measure of angle ABC. That's this guy over here. I'll mark it in red. ABC. Well, I know in similar figures that all angles have a corresponding congruent partner, right? So I know that angle ABC, that's going to have to be equal, I'll stay red. It's going to have to be equal to the measure of angle ADE. So let's start with that one. How could we solve for that? Well, I know this angle up here is 40. This one is 32. So the measure of angle ADE is going to be 40 plus 32, plus 40 plus 32 equals 180. So that angle must be 180 minus 72, or 108 degrees. And then again over here, we know they both equal each other, so 108 degrees. Those two are congruent and corresponding. All right, next they're talking to us about perimeter. Remember, perimeter is just adding up all of the edges of a polygon. So they're telling us the perimeter is 42.4 units. Find the perimeter of ADE. Okay, even with perimeter, I can use my scale factor. So, because I'm just adding up side lengths, if I know the perimeter of ABC is 42.4 units, that is going to compare to the perimeter of ADE, I'll call that x, by the same ratio as our scale factor. And now again, we're just going to butterfly method, and we're going to get 4x equals, throw this in your calculator, 296.8. When we divide both sides by 4, we're going to get 74.2. So the perimeter of triangle ADE equals 74.2 units. Alrighty, I'm going to actually skip part E. That's something that we're going to talk about a little bit more in some future sections. So we'll get there when we get there. But if I'm squaring stuff, it's going to look a little bit different. So we're just going to skip that one for today. We'll move on to F. Okay, is BC parallel to DE? So this line over here, is BC parallel to DE? Why or why not? Well, we already said in a previous problem that angle ABC and ADE are congruent to each other. We could also say that angle AED and ACB are congruent to each other. Using either one of those, yes, I would have to say yes, BC is parallel to DE because I have some congruent, consecutive, or corresponding angles. I'm going to look at the corresponding ones. So by corresponding angles. All right. So you guys have a couple more practice things online. You have your homework assignment. Don't start your homework assignment until the practice packet is done. The practice problems are giving you some different types of problems. The key to that will also be posted. And your solution manual for the homework won't be posted. We'll check that on Monday. So see you guys then.